All right, so we are recording class. Anything you say or do will be caught on the microwave. Microphone, thank you. All right, so we talked before lunch. Keep an eye on the weather so we can make some valid predictions tomorrow. Keep an eye on the highs and lows. That'll make a good effect on things. Yeah, we'll predict tomorrow. All right, we're starting angle relationships. This is day 1. Day 2 is tomorrow. Day 3 is supposed to be Friday. We'll see what happens. And what we do next week will depend on what happens with the weather. And everybody should have their packet pages numbered 1 to 14. That means like on your first sheet of paper, the front's 1, the back's 2. It's the first thing you were supposed to do when you came in. If you didn't do it, you didn't follow directions. Wonderful. Okay, before we get into angle relationships, I want us to look at some basics about angles. This first slide, the first box on the top left of your notes, it does give you the definition of an angle. It also gives you the symbol for an angle. The symbol for an angle looks like the less than symbol, except it's a little bit longer and it is flat on the bottom. What I want us to look at on this is how we name the angles. That's what I'm more concerned about on this page, because as we continue through a lot of these problems over the next few days and the coming weeks and whatnot, if we mention an angle and you don't know how to find that in a picture, you're going to get stuck, okay? This particular angle here, first I'm going to start on the far right, could be called angle 1. And that's because it has a 1 inside the angle here. There's no degree sign, so this is not a 1 degree angle. It's just identifying it with a 1. It can also be identified as angle C. C is the vertex. If I have an angle by itself, I can name it by its vertex. But I can also have naming angles based on the 3 letters. This one could be angle ECD, but it can also be called angle DCE. DCE or ECD. What do these two names, other than 3 letters, obviously they have in common, but they have something very specific in common with the letters? Wesley?
They're in order.
Okay. They do go in order, but even more specific. Charlie?
They're all the same angle.
They are. I'm talking about in its name. Mary Lady?
DCE is ECD backwards.
Okay. Chase? Okay. What's the middle letter? Okay, that's what we need to look at. When I name an angle, the vertex has to be the middle letter.
What's the vertex?
The vertex is the point of the angle. I've got it marked in red on the screen. Guys, not today. The vertex has to be the middle letter. If I look at these and I say angle CED, I've just looked at something completely different. Okay? So vertex must be the middle letter. And we're going to be naming angles while we kind of review over these. All right, types of angles. These should be familiar to us from elementary school. You have acute angles, which are the ones that are between 0 and 90. They're your smaller angles. What if I have an angle that is 89.99 degrees? It is still acute. In order to be a right angle, it must be exactly 90 degrees, not rounded to 90 degrees. Okay? What can identify a right angle for us? Something very specific that can identify it. Miriam?
If you can make a square where the point, where the vertex is.
Yeah, it would have a square in there. Just like on this angle right here, that square is identifying it as a right angle. One problem we're going to run into with geometry is we're going to want to look at something and assume we know what it is. With geometry, just like in English class, if you make a conclusion in English class, your English teacher is going to be like, all right, what evidence do you have to support that? In geometry, I want evidence to support what you say. Okay? And that gets more important when you get into geometry in high school. So when I ask you questions throughout these things, I want you justifying and giving me solid evidence and everything. And I bring that up because I can draw this on the board and people are like, oh, that's a right angle.
No, it's not.
Is there anything in it telling me that it's a right angle?
No.
Did I say it was a right angle? No.
Just like a square could be a rectangle.
Now, if I put the box in the corner, now it can be claimed to be a right angle. So I have to have support for these assumptions that I make. You have to go by the information you are told, not what you assume it to be. Okay? And if there's any questions on, stuff that we're working on, I'll clear that up for you. Now, on the right angle, what are some names of that right angle? Give me a name for it. Wesley?
ABC.
Okay, I have angle A, B, C. Micah?
CBA.
Angle C, B, A. Jimmy? Angle B.
Whoa.
3 names for that angle.
I get it now.
Okay?
Because the whatever it's called is the B.
The vertex is the B.
Because the B has to be the same. Because the vertex has it has to be the same in both.
Yeah, the vertex has to be the middle letter. And if it's an angle by itself, I can just call it by its vertex. Okay? So we've got acute angles, we got right angles. So obviously we have to have obtuse angles. Obtuse angles are between 90 and 180. So if it's 90.001,
That is obtuse.
it is now obtuse. Give me some names for the obtuse angle on the screen. Marley, tell me one of them.
EFC.
Angle E, F, C. Another one. Tristan.
CFE.
Angle C, F, E. Juju.
Phil?
Angle F. Very good. What happens when the angle is exactly 180 degrees?
It's a straight.
It's now a straight angle. It is a straight line. Give me the names for this straight angle. Let's get some people I have not heard from yet. John Henry?
XYZ.
Okay, I've got angle X, Y, Z. Jonah?
ZYX.
Angle Z, Y, X. Malak? Angle Y. Very good. Okay, so nice little basic review here. And this is all going to be coming back. What we're going to do is now we're going to get into the relationships, which is going to be the focus of our studying. Okay? Starting with these, we're going to fill in the blanks, and I added some pictures in here to kind of help it make a little sense. If you have 2 angles, and the sum of the 2 angles is 90 degrees, we say that the angles are complementary. They're complementary. It is. They complement each other. Okay? If I look at this picture, what proof do I have that angle AOD is a complement to angle DOB? What proof do I have? Liza Jane?
Is it because they both have O in the middle?
Nope, it's not because they both have O in the middle. Zoe?
Because they add up to 90.
Yeah, because 30 plus 60 is 90. That proves they're complementary. Yes, ma'am.
But it's complementary if they make a right angle.
Correct. It's complementary if it makes a right angle. Now, name me, this does have a point to it, I promise. I want you to name me the 30-degree angle. Name it for me. Miriam, give me one name.
AOD.
AOD. John Henry? DOA. Right. Name me the 60-degree angle. Tristan. DOB. Micah? BOD. All right. There's one more angle in this picture. Oh, Tristan's hand shot up real fast. What's its name, Tristan?
AOB.
What is AOB?
A right angle.
It's the right triangle, or the right angle. So the 90-degree angle, we have AOB or BOA. If you notice, what can I not name any of these angles, Charlie?
O.
I can't name them O. Every one of them shares the same vertex. So if I said, Miriam, find me angle O. Well, it could be the 30-degree angle, it could be the 60-degree angle, or it could be the 90-degree angle. Okay? The previous angles, when it was one angle by itself, you can name it by its vertex. But when my picture has multiple angles and they all share the vertex, you cannot use just the vertex to name it. Does that make sense? Okay. Let's look at the next one. We've got the sum of two angles is 180 degrees. We know what this is, guys? What is it?
Straight line.
Supplementary. Pretty good.
Why is it called
Sup. I did not come up with these, so I really have no idea.
How are they different? Because it makes a 180.
Because they add up to 180. So complementary, they make corners. They make 90 degrees. Supplementary makes straight lines to keep those S's and those C's together.
So the C corner is straight.
And they have to add up to 180. So if I look at my picture, angle AOB is a supplement to BOC because 65 plus 115 is 180. That makes them supplementary. Okay? All right, just to make sure we do not confuse these. All right, you always have to have random crazy ways on remembering these things. All right, make an L with your fingers. I pointed at somebody. Y'all are being so mean to each other. Don't you love it? You be mean. All right, no, like this.
I feel like I'm being ganged up on.
Okay, you're being ganged up on. You feel like you're being called a what?
L.
You feel like you're being called a loser. But, this is a compliment in math. Why? It's a right angle. So in math, you can hold up an L all day long at somebody and you're complimenting them. Aww.
Technically, if you take two right angles,
It's a whatever.
no, it's a win.
It's a win. I like it. Two L's make a win. All right.
I have something really important.
All right, you're telling everybody on YouTube right now. Okay, what is it, Mary Lady? Aw, she complimented me. So sweet.
Everyone give the L.
I get the L. I'm so sweet.
Subscribe to you.
I appreciate it. All right,
I didn't subscribe to you. I apologize.
that's okay.
I should.
Okay,
Is your name Jocelyn Short?
Shoshquin Short. No, it is not. I'll have to try changing that sometime.
Yep.
Okay, let's look at the next box. We're gonna try a couple problems. And one thing you're gonna see, you're gonna be like, why are you doing all this extra work when I write these? It's because we're gonna be getting into equation writing tomorrow. So we're just gonna kind of see how it starts to set up. On number one, if A and B are supplementary, what's that supplementary tell us? Straight, 180. Okay, so it is telling me that angle A plus angle B is 180 degrees. That's supplementary. Then it continues to say that the measure of angle A is 37. All right, so I've got 37, and I don't know what angle B is. Notice how the equations appear? But the simplest way to find the supplement to angle A, since I'm just using values, Miriam?
Do you have to do like
That's the symbol for angle. Mary Lady?
Can't you just subtract
Yeah. 180 minus 37, it gives you
143.
143. So here's some geometry symbols for you. We're going to explain it. Because the more we get into geometry, the more symbols you're going to be writing in. In blue, that's what it's telling you. The measure of angle B is 143 degrees. It's a math sentence written in symbols.
Well, then what's the import?
The measure of.
The measure of angle B equals 143.
There you go.
It's kind of like x equals whatever.
Yeah, kind of in a way. But we're writing sentences using math symbols. Nice and simple. All right. Number 2, we want to find the complement. What does it mean about complement?
Adds to 90.
Adds to 90. So we have angle A, and we want to add it to its complement. So we'll just say angle C, and they have to equal 90. But what do we know about angle A? Angle A is 37. And we're looking for the complement, so they equal 90. How are we going to find the complement to the 37 degrees? Emerson? 90 minus 37 is? 53. All right, so the measure of what we're saying is angle C is 53 degrees. Say what? Miriam.
Why does I like use 37?
It's just the number in the problem.
Wait, find the. A is 37.
Yeah, it's just using the same angle from the previous problem.
Where we can't see.
I made it up because they were looking for the complement, and I already used A and B, so I used a C. Don't overthink it. C stands for complement. It just seemed.
Trying to find out angle A, taking angle A plus whatever equals 97. Angle A equals 37.
Correct.
Oh wait, so a complement is
90. A compliment is 90 degrees.
Let Emerson talk about it.
Okay, wait. So like, if we had a quizzes about this, can you type like the angle symbol on the computer?
I don't think I would have you do that on quizzes. I'm not sure that symbol's on there. I really haven't looked.
So what would you do on test?
I think I've seen it before.
Usually on your test, you're just typing in a number on these.
I'm confused. So is the complement
Shh.
to A, if the complement to A
Is 53, because if A is 37, 90 minus 37 is 53. That way, a 37-degree angle plus a 53-degree angle equals 90 degrees.
Oh, I get it now.
She's good now. Random question on here. Can angle B have a complement? It's all angle B is 143 degrees. It's over 90. It's too big to have a complement,
Wait, it can have a supplement.
which is this 37 degrees up there. Can angle C have a supplement?
No.
Yes.
Yes.
Because it's less than 3.
is it's less than 180. So what is the supplement to angle C, Marley?
So I have a question. Can anything have a supplement as long as it's not already 180?
Correct. But not everything can have a complement unless it's less than 90. All right, so what's the supplement to the 53-degree angle? Wesley?
127.
127. All right, let's move on. So we've got supplementary, we've got complementary. Our next one, these are adjacent angles. Not Jason angles. Adjacent. Adjacent. Okay. Now, adjacent angles are simply two angles that are side by side. They share a vertex and they share a side, but they don't overlap each other. So if I color code these, I've got angle 1, I'm doing in red, and angle 2, I'm doing in yellow. Okay,
Wait, that was
hold up. Do they share the same vertex? Yes, they share that center point. That's their vertex. And if you notice that one side that's between them is both red and yellow because they both have that as a side. That's what makes them adjacent. If 1 and 2 are adjacent, tell me another pair of angles that are also adjacent. Mary Liddy?
1 and 4.
1 and 4 are adjacent. Any other pairs of adjacent angles? Micah? 2 and 4? 2 and 4 share a vertex, but they do not share a side because they are across from each other. 2 and 3. Liza Jane? Ma'am?
4 and 3.
4 and 3. Very good. Those are all the adjacent pairs in this picture. Now, there's something on the bottom of the screen. I'm going to lift it up so the back can see it. The fact that they are adjacent does not help in angle measure. I'm going to leave it there for just a minute. The fact that they're adjacent is just telling us their location to each other. But it does not help me in terms of their size. Okay? That's just the fun fact of it. Now, can I have supplementary angles that are adjacent to each other? Yes.
Yeah.
Can I have complementary angles that are adjacent to each other? Yes.
Oh, yes.
I mean, I can draw those. I mean, I can have complementary angles like they're in purple. Those two angles are adjacent and they're complementary. These two angles are adjacent and they're supplementary. But if I just give you this, well, it's an obtuse angle that's been cut, so it's two angles that are adjacent, but I have no idea anything about their measurement.
Wait, well, one was
Maybe.
on the right and both the way. No.
You're going into assumptions. There is nothing on there that shows you anything about right angles.
What was the up
I know, it just
Ma'am?
So would that one, like with that circle thing on it, be adjacent because it's like one side of the line is
It's-
one side of the line?
It's adjacent because of this part right here that's in blue. Because the angle on the left, the smaller angle, and the angle on the right, the bigger angle, share that line. That makes them adjacent.
Oh,
because it's a straight angle and then
I was thinking about it being like this
Exactly, but that's,
See what I'm saying?
yeah, but that's the point in that I'm trying to make here is that complementary angles can be adjacent. That's fine. Supplementary angles can be adjacent. That's fine. But being just adjacent to each other does not help me in measurements. Okay?
Okay.
All right.
Figure it out eventually.
To be honest, the concept of adjacent is the least term I'm worried about. Okay? I am more concerned about you guys retaining and practicing supplementary, which is what key number?
180.
Complementary? 90. And our next vocabulary term that we're fixing to do, which is same picture, but these are vertical angles. Okay.
Oh, so it's what I was saying.
Vertical angles are formed when lines intersect each other and form angles. In this picture, you have two lines that have completely crossed that have intersected each other. 4 angles have appeared, and they've got them named 1, 2, 3, and 4. The vertical angles are the ones that are opposite of each other. And it tells us to focus on angle 1 and 3. 1 and 3 are opposite of each other. They're vertical to each other. What that is telling me is that the measure of angle 1 is equal to the measure of angle 3.
In 2 and 4 also.
Okay, so then 4 and 2 would be equal?
There you go. Good job, you two. 4 and 2 are also across from each other. So they're vertical. So the measure of angle 2 is equal to the measure of angle 4.
It looks like one, like, okay, let me rephrase that. It looks like it's really hard, but it's really not.
It's not.
You just have to know what it means.
So, is there a way you can do a vertical angle and it won't be like an X?
Now, you'll see tomorrow, there will be vertical angles, and I'll have like 3 intersecting lines. And when that happens, you end up with 6 angles, and you end up with 3 pairs of vertical angles. But when we get to that, we'll be color coding them so you can kind of see it a little bit better.
Okay.
Okay? All right. We're going to practice some vertical angle practice. Since they don't add up to 90, they don't add up to 180, they're equal to each other. We got a whole bunch of different ideas that we can use here. It says to find the measures of angles 1, 2, and 3. But the only thing they've told us is that angle 4 is 128 degrees.
2 is equal.
Why do you say 2 is equal to it?
They're vertical.
Because they're vertical. All right, so the measure of angle 2,
Mine can only be 360.
Oh.
hold up. All right, slow it down, Speedy.
Sorry.
Okay, if 2 and 4 are vertical, as Micah said, they're the same measurement. What does it tell us about 1 and 3? All right, they're vertical, so they're the same. Okay? It's badly drawn, but what is in the center of the picture? A circle. Okay, what I have noticed over the years is it takes us a minute to see the simple way to do this, but we hone in real fast on the more difficult way of doing this. We see the circle. What do you know about the degrees of a circle? 360. Okay, well, all right, so a person talking. I got a bunch of O's. They're seeing the 360. They're seeing the circles. What are you going to add? Mary Liddy? Okay. All right, as Mary Liddy said, she's starting us out right. 128 plus 128 is going to get me 256. Not 265. Having a moment. Okay, that's a start. I love it when we see the circle and we immediately know what to do. Liza Jane, what would you do next?
Then subtract it from 360.
Okay, remove those two pieces from the full circle. That's going to leave me with 104. Why are we dividing it by 2? Zoe?
Because there's 2 of them.
There's 2 equal angles we have to cover. So 104 divided by 2. 52 degrees. Okay. Which means angle 3 is how big? 52 degrees. It's amazing when my students see the circle, this stuff becomes really, really easy. But y'all realize you're doing it the more difficult way, right?
Well,
All right, I'm leaving that up there for angle 1. I'm going to show you an alternate method for angle 3. Okay? The full circle is how much?
360.
Is 360. Okay, so that fabulous circle, I'm going to go down one of my lines right here.
Yes, ma'am.
And if I go down this highlighted line, what did I just do to my circle?
Cut it in half.
Okay, so I have a semicircle. I have half, boys and girls, I have half a circle right there. Okay? How much is half a circle? 180. So if angles 2 and 3 make up the 180, how can you find the missing part? Subtract what?
128.
Wait, no, 128. Wait, no, 180 from 128.
Reverse it, but 180 minus 128, and you still get your 52 degrees.
I think the other way is easier. Yeah.
And that's the thing is some of us like the full circle, and actually the full circle is going to help when I start giving you the questions where I've got lines everywhere. If you hone in on that circle, I think you're going to flush out a lot of things a little bit better. Okay? But then some of us are going to have an easy time seeing the half circles. We do what works best for us. I just present all options. Okay? All right, you try the next one. Right here. I'm going to pause the video for just a minute and give you guys a chance to go over this before somebody explains their method. Okay.
Dude, but like,
All right, on here we have angle 8 is 72 degrees. I need someone to guide me through how they process through the question. Oh, all these hands. Marley.
So I saw the straight line and I did the half circle. So I did
Okay, so you said you found the half circle.
yeah.
Okay.
And so since the straight line or the half circle is 180 degrees, I did 180 minus 72, and then I got 108. And then I checked my work by adding all of the angles together.
Okay, well that gives me angles 5 and 8, so how did you know 6 and 7?
Because they're vertical, so they're the ones that are vertical from each other are equal.
Very good. Vertical angles are equal. Despite which method you used, those are the answers that you should have gotten. And I like how she said she checked her work. She added up all 4 numbers and got 360. Got to have that full circle. Very good. Okay, we're going to skip the next 2 boxes on that handout, so I want you to turn to the next page. Just flip your packets over. And,
So 3?
yes, page 3. On part A, we want to find the complement or supplement for each angle. The complement or supplement. If I ask for the supplement of a 29-degree angle, how am I going to find that? That's Micah.
Subtract 180 from 29.
Subtract it from 180. Okay. So 180 minus 29. And my supplement is how much? Juju? $151 degrees. Okay. How would I find the complement of the 55-degree angle? Liza?
Wait. 90 minus 55.
Very good. 90 minus 55 gave you how much?
35.
35 degrees. Very good. Do the next two. I'm going to ask for answers in about 30 seconds. And I'll even pause it for 30 seconds. Okay, the complement of a 43-degree angle. What did you get as your answer, Miriam?
47 degrees.
47 degrees. Very good. And number 4, John Henry, the supplement to 112 degrees. 68 degrees. Okay, random question.
Yes.
I like the random questions. Michael, you want the random question?
Sure.
What's the complement to the 112-degree angle?
There's no complement.
There's no complement. Very good. All right. Part B, middle section. We just want to tell if they're complementary or supplementary. So, what do you need to do with the two given angles?
Add them.
Add them. Which number do they line up with, the 90 or the 180? That's what I want you to find.
Can we write C or S?
C or S works for me, yes. I'm going to pause for about 30 seconds. Okay, let's look at the first pair of numbers. Brissa, is the first pair complementary or supplementary? Ma'am? They're complementary. Number 2. Charlie?
It's supplementary.
They're supplementary. Number 3, Sarah? Supplementary. Number 4, Millie? Very good. Complementary has to add up to what value? 90 degrees. Supplementary. 180 degrees. What do I know about vertical angles? They share that vertex, but what about their measurements? They're equal measurements when they're vertical. Very good. All right, bottom set. Okay, this is very much like the first set of problems, except it's more in the structure that I would present problems to you in. All right, so I'm going to give you probably less than a minute on these. There you go. Okie dokie, question number 1, Jason. Jason, how did you find your answer?
I did 90 minus 36.
That will work. And what'd you get?
54 degrees.
54 degrees. That works. All right. So if I wanted to write this nicely, I'd put M angle 1 equals 54 degrees. So the measure of angle 1 is 54 degrees. How about number 2? Mary Lady.
So what I did was I wrote it out as like the 1 plus what angle 1 plus angle 2 equals 180.
Okay.
Then I put 41 plus angle 2 equals 180. And then subtracted 41 from 180, which gave me the measure of angle 2 equals 139.
What was he trying to say? He was
130 what, ma'am? The boys back here are talking. Thank you. Good. Good practice on the equations. When I say the equations are coming tomorrow, better get ready to draw them lines and start working those, because that's what we're going to be doing. Okay. We are jumping to page 10. Shh. Here's what we're going to do. Girls, I want you to do numbers 1 and 3. Boys, do 5 and 6.
I like it.
Yeah, girls are going to do 1 and 3. The guys are going to do 5 and 6.
Huh?
Mike is going to do all 6 questions on the page.
I will.
And in about 2 minutes, 2 to 3 minutes, I want to go over these and let you know what I need done before class tomorrow. Wait a minute, I want to change it. Now, just for time's sake, girls do question number 1, boys do question number 5, and then we're going to go over those 2 and leave the other 4 for future use. Okay? So 1 question. Okay, let's look at question 1. This one the girls had to do. So, all right,
Okay, Justine.
tell me how to solve it so I can put it on the screen so my folks at home can hear what you did.
Okay. So, if angle 2 equals 64, then angle 4 equals 64.
Why? What's their vocabulary relationship that we've been practicing? Any of the girls can help her.
Are they vertical?
They're vertical. Good.
So vertical has to be the side.
No, adjacent is side by side. Vertical is across. All right. Now, how did you figure out 1 or 3?
I did the half circle method.
Okay, so half circle method. And that told you to do what?
If a full circle is 360 degrees and half a circle is 180 degrees, so I did what I already had, which was 180 minus 64, and that equals 116. So angle 1 equals 116, and angle 3 equals 116.
Very good. That's excellent job. Good explanation. Okay, I'm clicking through so the kids at home have the problems. And which one did I tell you guys to do, Chase? All right, Chase, you got number 5 for me. I have heard little from you today.
So it says
Shh.
angle 4 equals 43.
Correct?
So I put 43 around 4, and since 4 and 2 are vertical, I put 43 divided 2.
Very good.
I did 180 minus 43 equals 137.
Equals how much?
137.
Very good.
Then I put it around 3.
Excellent job.
So sigma.
How could you check your work?
Add them all together. And then
You can,
it equals 360.
perfect. Add all 4 of them up and see if you get 360. Okay. Now, a couple things, folks. Quit squeezing the bottle because this is going to affect something Wesley asked me about and something that Liza asked me about. First of all, pages 4 and 5 I need by class tomorrow. It honestly should take you 10 minutes or less. But your quizzes yesterday, did anybody keep getting the solve for X questions wrong?
Yes.
Would somebody who figured out why they were getting them wrong tell everybody why they're getting them wrong, Jimmy?
I forgot X equals, yeah.
As we talked last semester, when we are solving for equations, you got to state your answer. Variable equals your solution. So every one of those that said solve for X, you might have gotten 1 or 15. You had the right answer, but you got to put X equals 1, X equals 15, X equals negative 10. Okay?
Yes.
That's why you're missing those. I have the quizzes back open until Friday at 8 a.m. Give you something to do when it starts snowing. See what happens.
Yeah, no, I'm gonna be on my
All right. Hey, time out. Supplies in the correct boxes and chairs in the desks, and keep your voices down, please.